You recorded?
Mm-hmm.
Oh, sorry, started again, so I didn't know you were going.
That's right.
Okay, in this video we're going to take a quick look at the ECU Genius test rig, shortly to be available from Blue Hawk Electronics. The test rig itself is controlled from a PC with a graphical interface, as you can see on the screen here. This graphical interface enables us to control all of the inputs to the ECU under test. And as you can see on this panel, we have controls for various power supplies, battery ignition and starter, as well as relay override switches and various controls and sliders which represent the various sensors to the ECU under test, as well as engine speed signals. If we just sweep the camera around and look at the actual rig itself, we'll see that it's connected to the PC just through a single USB cable, which makes connection very easy. We've got no ECU hooked up to the rig at the moment, but a new video will follow very shortly showing us testing an actual ECU. So let's just have a quick look at how we communicate to the rig via the PC panel. You can actually see while we're looking at the rig there that there are a number of connectors on the front panel which are used to connect the various signals to the ECU under test. One of the connectors is all the power supplies. Another one is for discrete input signals, that is, signals that just switch high or low. And then one that takes analog signals to the ECU under test. And finally some connectors which read back the outputs from the ECU under test to drive the various ignition, injector and other loads in the rig. We also have connections for a serial OBD scan tool. And as we just try and zoom in, you can probably see a little closer there. We have LEDs on the front panel as well, which represent the various outputs to the ECU and feedback signals from the ECU. And you can see there that we have a standard OBD socket. Okay, let's take a look at the front panel again on the PC. And we can manually control all of these things. For example, battery power. We'll switch on the battery power and it will be confirmed by an LED on the front panel. Ignition power and the starter discrete. We also have facilities to override the fuel and main relays in case the ECU under test has a fault with that. We can just override those functions and then continue to test everything else. We have a number of discrete inputs which we can switch on and off. You can see that at the top right of the display on the rig, we have a number of LEDs representing a system bus. Now, the way we communicate, we actually send commands through the USB cable, but those are received by the rig and converted to an address which is 4 bits and data lines which are 8 bits. What we actually have, the way that this is configured internally, is that the boards inside the rig each correspond to a certain address. Board select lines 0 through 8. Those are represented by these LEDs right at the top of the unit along here. So internally we have a number of boards which we select one of them, and then once we've selected one of those, we select an address which is between 0 and 15 by the 4 LEDs here, the 4 lines here, and then we write data to each board, which is an 8-bit number. Now every time we write anything to the rig, for example if I switch battery power on, you can see that at the top right we see line D0 on, and the address lines are all 0. That means I'm writing to a board 0 and the address 0 on that board, and I'm putting out the bit 1 on that board, which corresponds to the battery signal. If I actually control something like a DC voltage by sweeping a potentiometer control up and down, you can see that those lines move continuously as I sweep this control. So if you look at the actual control here, you can see that I'm sweeping the slider up and down to control DC voltage, and that's corresponding on the rig to putting out different values for that location on the board. If I use a different slider, you'll see it's a different address it's writing to. It's now address 1, whereas the first slider corresponded to 0. So that's 1, that's 0. And its controls going out to board number 2, which is the analog input board. We also have the facility with the rig to actually run test scripts. Let's have a look at the test script that we wrote. Don't know if we can see this on the screen. So this test script is actually just doing a very simple thing. It's switching the battery on. It's waiting 2 seconds. Switching the ignition power on. Waiting 2 seconds. Switching the starter on. Waiting 2 seconds. Switching the starter off. Waiting 2 seconds. Then ramping the DC vacuum signal number 1 over a period of 10 seconds to a maximum value. Waiting 15 seconds as to allow the ramp to complete, and then ramping back down again, then switching ignition off, waiting and switching battery off. So let's just run that test and see what it does. So we select the test and we run it. And looking at the rig, let's switch the battery on, ignition on, starter on. It's now going to do that ramp command, which you can't actually see the outputs, but we can monitor what's happening with those LEDs at top right. The DC vacuum signal from the rig is now being ramped over a period of 10 seconds. It's staying at maximum, and it's going to ramp down again. When that ramp completes, it will now switch off the ignition power. A few seconds, there it goes, and then switch off the battery power. And you see how simple it is to write an automated test. We can put controls on all of the outputs in the same way. So that's just a quick overview. In a video that we'll produce very shortly, we'll show us actually testing an ECU, so we can actually see a real ECU being tested and monitoring real inputs and outputs and driving the internal injectors and ignition loads. Thank you very much.